Previously, we looked at Taylor series. Now we're going to look at the error bound, where if we use a Taylor polynomial to approximate it. So, much like an alternating series, the Taylor/Maclaurin series have a remainder or an error that is less than the next term. So in other words, if I'm using P5, the fifth Taylor polynomial, to estimate the function's value, the error will be less than P6, which is the next term, or sorry, not P6, A6, whereas A is the next term in the series. So we can write that more generally as in the Taylor series. I should write this as an S. So the series, whatever the series sums to, minus P sub n will be less than or equal to A sub n plus 1. This is if S equals the infinite sum from n equals 0 to infinity of A sub n. And if P sub n is equal to the sum of n equals 0 to, that's going to be confusing. Let's call this I. So I plus 1. So the series is just all the terms add together. And if we go in this case, P sub I will be from n equals 0 to term I. So we're only summing some of it. So if I sum up to the fifth polynomial, the error is less than or equal to the next term. And this is just like we saw before, so there might be questions on the AP test of, prove that the error, that, this expression right here, prove that this is true, and they'll give you some values. And all you have to do is figure out this PI is that the first, second, third, fourth, fifth, 10th, 100th, whatever it is, and then just find the next term in the series, and you know that this expression has to be less than that term. This is something that once you practice a couple AP tests, you should pick up on the pattern, and it's fairly simple, but it's something that will make more sense with practice as opposed to explanation.